Welcome to this session where we're going to introduce Cucumber and how it can be used to help you implement behaviour-driven development. We'll specifically look at what behaviour-driven development is, we'll look at the benefits of behaviour-driven development, the relationship between BDD and other practices such as TDD. We'll also look at Cucumber obviously, and then we'll look at with Cucumber how you define features and scenarios and what those mean, those words mean in this context, and then linking features and scenarios to tests. So, starting off, what is behaviour-driven development? It's essentially a process by which you specify the required behaviours of your system in a form that allows an application to be developed and tested to conform to those behaviours. And testing for the adherence to these requirements is then automated. So, in other words, you capture your requirements in a textual form, and then that textual form can also become your tests, which can then be run in an automatic way. Okay, so we'll see an example as we go through. So some of the benefits of this approach, firstly, you get automatic or automated functional testing, or automated testing. So once you've written these requirements in this form, you can create tests, and then those tests can be run whenever you want from a continuous integration server. So you could have a single-click deployment model where the tests get run before any deployment goes through. So it also means when you do behaviour-driven development that your application only does what is required, because what you do is you specify your requirements in these documents and then essentially ensure that your application meets those requirements. If it does meet those requirements and passes those tests, then it does what's needed. It doesn't need to do anything else. So your entire functional requirements, and even non-functional potentially requirements, can be captured and the tests be automated using behaviour-driven development. And the behavioural requirements are captured in a format understood by technologists and business people alike. So all stakeholders can read and understand these documents that you create, called feature files. So, and then lastly, in their benefits, the test cases are defined up front and the requirements are also the test cases, and this is a key benefit. Your requirement specification is also your examples of how the system will work and is also the test cases. So rather than have to write requirements, then provide some examples and then provide some test cases, you can provide all of that in one document that everybody in this, all the stakeholders can relate to and understand. Now, how this relates to other practices, those of you who are developers or work with developers might have heard of or come across or done even test-driven development. Now, test-driven development and behaviour-driven development are complementary approaches to your development process. So, BDD does relate to other practices. It relates well to test-driven development as an approach as well. So, for example, you would specify your system requirements as features using these documents I was talking about earlier, these feature documents, specifying what the system should do. And then once you've defined what the system should do, you then build out the system, and your system's going to be comprised of various classes. So if it's a 3-tier architecture Java or C# app, for example, there'll be controllers, service classes, repository classes, and so on. Those classes will then be developed using TDD to build out the system. So you've got unit tests for each of your individual classes that make up the system, and then you've got your behavioural tests to ensure that the overall system does what it needs to do. So BDD and TDD are complementary approaches to development, and they do work very well together. BDD also relates well to user stories. You may have, I'm sure, come across the term user stories. Many of you will have written and worked with user stories. User stories are a common way of capturing requirements in agile projects particularly. And with user stories you have what are called acceptance criteria that define whether a project has or a feature has been implemented correctly or not. Now it's those acceptance criteria that are written using this approach that we're talking about, these features. So these feature files are actually the acceptance criteria for user stories. But the question is, how do you capture these features? I keep talking about these feature documents. What are they? And how do you use them? Well, we'll see what they are. We'll see an example. And this is where Cucumber comes in. Cucumber is a testing framework that allows you to write these features in plain text, in English usually, and then implement the automation of that test in a programming language like Java or C# or whatever you choose to use. So Cucumber facilitates the creation and running of these tests. Yeah, there's different languages supported. You can go to the cucumber.io website and you can see all about it. We'll look at an example in C# and we'll look at a tiny bit of Java as well, just to see how it can be done in that too. So the key artifact in a Cucumber based test is the feature file, as I've alluded to a couple of times already. This file is language agnostic. It's actually written in its own sort of language, actually, called Gherkin. Okay, so these feature files, they're written in Gherkin, and they specify the required behavior for a feature as a series of what are referred to as scenarios, which basically provide examples of how a system should work. So you end up with example-based specifications. So if we take an example, we'll take the example of a speaking clock. In the UK, we have this speaking clock. You phone a telephone number and it will tell you what the time is. A little bit archaic with modern technology, but it still exists. Now, if you had a speaking clock, that speaking clock would look at the time of day and then would need to say the correct time back to you. So, for example, if it was 12 p.m, the text that should be said back is midday. If it was 12 a.m, the text that should be read back is midnight. So we could capture, if we were building the speaking clock, we could capture what's meant to be said in the form of a feature file. So here is a speaking clock feature file specifying that the speaking clock should do midday and midnight correctly. So notice at the top we have a feature called speaking clock, and then in there it just says, in order to get the time as text, I want to be able to pass a date time so that I can get a suitable string back. We've written it, if you might have noticed, in the form of a user story. We've then got the scenarios underneath. So the first scenario is converting midnight to text. So given that the time is 0 hours and 0 minutes, when I request the time, then the result should be midnight. The one underneath is for midday. So given the time is 12 hours and no minutes, when I request the time, the result should be midday. That would be saved as a file called something like speakingclock.feature. The extension on these files by convention is feature. So the top level part of the feature describes the overall functionality, so it's the user story if you like. It's not read by a machine, but it can appear in your automated test results. Then you've got the scenarios. Now we saw that they had, if we go back, given, when, then. If you see that in the middle there, given something, when, this situation, then, and so on. So these given, when, thens, the given is where you arrange the test, so you'd set up the speaking clock. You might need more steps, so you can have ands in there if you need them. So once you've set the clock up, when, so the when is where you specify the action. So when it's midnight or when it's midday, so that's you specifying what should be done, and then you assert what the result should be. So then I expect the text midday, or then I expect the text midnight. It's actually very similar to what in test-driven development you might recognize as the arrange, act, assert model. If you've done TDD, you'll know that in a unit test you'll arrange the things to be tested, do the action, and then assert the result. So arrange the thing to be tested, set up the clock. Act, ask it for the time when it's midnight. Assert, check that the text midnight comes back. Arrange, act, assert. BDD follows the same kind of approach. So we've got our example. Given the time is 0 hours and 0 minutes, when I request the time, the result should be midnight. So given, when, then, let's have a look at how that would be implemented. Yeah, so these files, they're created by business people and technical people. Yeah, multiple stakeholders can contribute to these files. Each feature will have multiple scenarios that capture examples of how it should work. One thing you should consider when you create these feature files is to ensure that you use a common terminology so that the feature files all use the same words for the same things. It makes it much easier to write the code that runs in the background. And it's the code that runs in the background that we need to look at next. So the code needs to be written. The code is called a step flow definition, and these can be written in the supported languages of Cucumber. So we will look at a step flow definition written in C#. So here's the speaking clock step flow definition. We can see 3 methods, one for given, one for when, and one for then. And you can see we use attributes above these methods to specify what they're for. So given, whens, and thens. And we can also see regular expressions. You see these text values here. These are regex or regular expressions. So there's a string pattern matching technology if you're not familiar with it. So here we're saying given the time is, and then we've got a parameter, hours, and another parameter, minutes. So what happens here is that this method reads, well, the framework reads the text from the feature file, and then these values get passed in as parameters into the method. And so these parameters can be used to set up a clock and request the time from the clock. Here, when I request the time, so this is where we actually explicitly ask the clock for the time, then the result should be, and then we get another parameter value here which goes in as a string, so we can assert what we expect that result to be. So if we look at these steps, so each step is processed by a given, when, and then attribute. Each attribute contains the regular expression, as we saw, with the pattern matching the text in the scenario. Parameter values are then in parentheses, which are then automatically available as method parameters, as you can see in the example down here. So this attribute's got 2 values in parentheses. Dot star means a character followed by any number of characters, so any characters between is and hours, and then any more between and minutes, they go into here, an int and an int, so 2 ints, hours and minutes will be set. So then in the methods we can now start setting up our system. So in this one we're creating a date in the first bit, and then we're creating our speaking clock, which is the system we want to test. And then what we do is we ask the speaking clock for the time as text for the particular date that was set up here. So when I request the time, which is what we're doing here, we get a string back, and then we assert that the string we got back is what we expected. So obviously there'll be some variables in the code showing what we actually expected it to be. So, and there's the speaking clock. It only actually does midday and midnight, so it's only correct twice a day. So there's, you can see, it's not particularly important, but that's the class we're actually testing. It just checks the hours and minutes. If they're 0 and 0, it's midnight. If it's 12 and 0, it's midday. Now, to use this in Visual Studio, you need to set up the SpecFlow Cucumber tools. You just install it as an add-in. Then in the project itself, you add a couple of references, one to techtalk.specflow and one to techtalk.specflow runner. And then there are wizards to help you create the feature files and the step flow definition. So actually, once you've written a feature file, the step flow class can be generated automatically straight out of the feature files. Very useful. In Java, we need a couple of dependencies. So you can see there's a Cucumber JUnit extension down the bottom there, and a Cucumber for Java dependency as well. You add those, and if it's Maven anyway, that's how you do it, and your projects will then have Cucumber added. IntelliJ and Eclipse have plugins available to work with Cucumber from Java. And in Java code, just to give you a flavour of the step flow definitions, you can see in this example the code is very similar. We use annotations instead of attributes. Here's a when, and then we've got a regular expression, takes in 2 parameters. Those 2 parameters go into this method as date objects. So we interestingly, you're just converting values straight into dates. So again, Java uses very similar to approach to C#. In fact, the scenarios themselves are written in exactly the same way. Now, the other thing you can do with Cucumber and scenarios is work with data sets. If we think about our time example, the one we're just doing, the speaking clock, there could be lots of possible times you'd need to check. Half past this and quarter to that and 20 past this and bang on this hour and so on. And to try and write a scenario for every single one would be quite time consuming. It would be a lot easier if you could just provide a table of values, something along these lines. So here's a scenario. So we've got, given I've been provided this set of times and expected results, and then we provide in the scenario a table. These vertical bars very simple syntax, denote the first row, which is the column names, and the second rows and third rows and so on are the actual values. Now what we can do when we create these tables is, if we write a C# class to match, or a Java class, this works in Java too, if we write a class to match the table with the same names, then what can happen is automatically each row becomes an instance of that class below automatically. So let's look at a method that would do that. So here is the attribute given, and then I've been provided with a set of times. Then in the method it takes in a parameter which is a table. Now this table is a SpecFlow class. It's provided by the SpecFlow library, and it has a method createSet, and you specify the class name that it's a set of, and then you can turn that into a list with the toList method. So that gives you a list of the timetable. Now timetable was my class. Yeah, so we get a list of those objects back. So that automatically gets created, and then in our test method we can then use that list, iterate through the list, and process all the values and check that they are correct. So if we found that our speaking clock, for example, was failing at a particular time, we could add that time to our list and then recreate the failure, fix the problem, and then that is now sorted and the test will now pass. But again, it's all automatic. Okay, so here in Visual Studio is a project with the example that we've been talking about in. Notice on the right hand side we can see the feature file, speakingclock.feature. Notice it's got this icon. That's because we've added in the SpecFlow plugin to Visual Studio, which recognizes these files. If we open the file, you can see it on the left here. It's got the feature that I was going through earlier, the convert to midnight, convert to midday, and a table with some times in, just like we saw. Now I've then got the steps again, so I open that. Here's the actual C# full class with the steps in it. So given the time is this and this, the hours are that and that. When I request the time, so request the time, the result should be, and we assert the time. This code is shared through our blog on this very topic, so you can grab the code from there if you wish to see it in more detail. So anyway, there's the example. To run the tests, all I need to do is go to the feature file, right click, run SpecFlow scenarios, and it will now run my test. I'm in the evaluation mode of SpecFlow, so it always puts a little delay in when you run it. There we go, so it's running the tests. They all passed, so 3 succeeded. If we go to the Test Explorer, there they all are. 3 working tests, yeah, all passed. Okay, so hopefully that illustrates to you how the thing can be put together. So what we've seen is what behavior-driven development is about. Just briefly, we've looked at some of the benefits of behavior-driven development, being able to automate your functional tests, your requirements acting as test specifications and examples. So the one document is 3 things. We've seen the relationship between BDD and TDD specifically, and user story creation. We've looked at Cucumber as a technology choice to allow you to create these automated tests for your behaviors, and we've seen how you define features and scenarios using Cucumber, and we've seen in Visual Studio how to link our features and scenarios to tests with these step flow definitions. Hope you've enjoyed this session. We run training courses on this subject at Coniger.com, so please head over to our website and you can find out more about the training. We also have blogs on some of this content, so you can have a look and see more information on that as well. Thank you so much for joining us for this session.